This is Mr. Beck Does Your Homework. This is AP Physics Homework 12.2 about double slit and thin film. This is questions 1 and 2. The question asks, a pair of narrow parallel slits separated by 0.166 millimeters are illuminated by green light of wavelength 554 nanometers. An interference pattern is observed on a screen 1.26 meters away from the plane of the slits. Calculate the distance from the central maximum to the first bright region on either side of the central maximum. So for any double slit problem, we're going to have a setup like this, where D is the distance between the slits, X is going to be how far away from the center I get a bright fringe or a dark fringe or something like that. L is going to be the distance to the screen. So what we have here is the parallel slits are separated by a distance of 0.166 millimeters. Be careful about units. So I'm going to write D equals 0.166, and instead of writing millimeters, I'm going to write times 10 to the minus 3 meters. So that's times 10 to the minus 3 meters. That way I'm going to put everything in meters and I'll be happy with what I've got the whole way through. So the next thing it says is that the green light is a wavelength of 554 nanometers. So again, I'm going to write my wavelength is 554, but instead of writing nanometers, I'm going to write times 10 to the minus 9 meters. Next, it says an interference pattern is observed on a screen 1.26 meters away. Well, that's how far it is. That's L is 1.26 meters. And then it says calculate the distance from the central maximum to the first bright region. First bright means that M is going to be 1. So I'm going to have one wavelength away will get me from the center maximum to the first bright region, because that's going to be a difference in path length between these two of 1 wavelength. So now I've got to do my calculation. The equation I have is that X, that distance I'm looking for, is M, which is how many wavelengths, times the wavelength itself, times how far it is to the screen, divided by the distance between the slits. When I plug in these numbers into X equals M lambda L over D, what I'm going to do is I'm going to get an answer that's in meters. But this says answer in units of millimeters. So to get from meters to millimeters, whatever I get here, I'm going to have to take that and times it by 1,000, because there are 1,000 millimeters in 1 meter. That should solve this question here, answer in units of millimeters. Part 2 says calculate the distance between the first and second dark bands. Well, this is interesting. For the first dark band, that would be at M equals 1/2. For the second dark band, that would be at M equals 1.5. So what I could do is take this formula, plug in my lambda, my L, and my D, and plug in 1/2 for M. Then I would do the same formula and plug in my lambda, my L, and my D, and plug in 1.5 for M. And then I want the distance between them. So to get the distance between them, what I would do is take that first answer and subtract the second answer. And what I'm going to find out is that that's going to be the same as if I took the distance that I'm really looking for is going to be M1 lambda L over D minus M2 lambda L over D. But you'll see that all of that collapses to M1 minus M2 times lambda L over D. Well, M1 minus M2, I think that 1.5 or 1/2 minus 1.5 is going to give me a difference of 1, and that's going to happen to be the same as this. So the point here is that from the central bright to the first bright is going to be the same distance as the first dark to the second dark. Is going to be the same as the distance between any two brights or any two darks anywhere along the way. So that is going to give you your answer to question number 2.